Hello everyone. Welcome to our session on threads in Java. The agenda for today's session is thread lifecycle, thread creation, multi-threading, synchronization in threads, and deadlock situation. So first we'll come to the thread lifecycle. The life cycle of a thread starts from the new state. That is, when a thread is created, it first goes to the new state. From there, when the start method is called, it comes to the runnable state. So we can create any number of threads, and when these threads are started, when we call the start method on these threads, they come to the runnable state. From the runnable state, when a thread gets its priority, that is according to the priority, the thread comes to the running state. Any of the threads starts running. So once it starts running, you can block a thread, or a thread can become brought to the blocked state or non-runnable state by calling the sleep method, block on input output, wait for lock, suspend, and wait methods. So these are the methods by which we can bring a thread which is running to the non-runnable or the blocked state. From the blocked state, again, it goes back to the runnable state when the sleep is done. That is, the sleep is always for a few seconds or milliseconds and all. So when that time is over, it goes to the runnable state. Or when the input output is complete, or the lock is available, or assume is method is called, or a notify or notify all methods are called. So in such situations, from the non-runnable state, a thread goes back to the runnable state. And from the runnable state, again, only when it gets priority, it can start running. So when it is in the running state, a thread actually executes what's written inside the run method. So, and when the code that is written inside the run method gets over, it comes to the exit or the stop state. And this is what is the terminated state. It calls the stop method and comes to the terminated state. So this is what is the life cycle of a thread. Now, we'll come to what is a thread. A thread is a lightweight subprocess, and it is the smallest independent unit of a program. And it contains a separate path of execution, and every Java program contains at least one thread. So, we'll come to what is thread creation. How can a thread be created? A thread can be created in two ways. That is either by extending the thread class or by implementing the runnable interface. The thread is an abstract class, and runnable is an interface. And both these thread class and the runnable interface, they contain the same run method, which has to be overridden in the class where it is implemented or extended, and the code that is written inside the run method, that is what is executed by that particular thread. Now, Java defines two ways of creating a thread. That is, we can implement the runnable interface or we can extend the thread class. Basically, more often we can implement the runnable interface. That's because Java doesn't support multiple inheritance, and since it doesn't support multiple inheritance, it's better that we implement runnable interface, because any number of interfaces can be implemented in a Java class. So if in a Java program it extends the JFrame or it extends the JPanel or an applet, if a Java class extends it, then it won't be able to extend the thread class. It can only implement the runnable interface. That's why it's almost always better to implement the runnable interface in the case of Java programs. Now, when come to multi-threading, what is multi-threading? Java provides a good support for multi-threaded programs, and a multi-threaded program can be divided into two or more parts that can run simultaneously or concurrently. So that is what is a multi-threaded program. Multi-threading means where a program can be divided into different threads, n number of threads, and these threads run concurrently. Then it is known as a multi-threaded application or a multi-threaded program. A multitasking is made possible just because of this multi-threading. And multitasking can be again divided into two, that is process-based multitasking and thread-based multitasking. Now, what is process-based multitasking? Just consider our system where we have the Word document running, and then we have our Explorer or the browser running, and then at the same time we can open the IDE, and n number of programs can be opened in our system. So this is where at a time we can run more than one tasks or processes, that is applications are being opened, is a very good example for process-based multitasking. And thread-based multitasking is what we can see in a simple Java program. When we come to Java programs and all, we see thread-based multitasking. That is, consider the example of a stack. A stack can have two methods, push and pop method. Push method is for inserting data and pop method is for retrieving the data. Now, if you in the stack, you have a simple character array, and a push method is for inserting the data A, B, C, D into it, and pop method is for retrieving the data A, B, C, D out of it. Now, the push and the pop methods of the same program can be divided into two threads. Can be made into two threads, and the push and the pop methods have to work concurrently. Then in such a situation, we can see thread-based multitasking. So basically, when we come to Java programming and all, we see thread-based multitasking. Here, we'll come to synchronization and all such things in our in the later parts of the session, of the same session. So there we'll speak about the same example. So that is what is. Now I just spoke about multitasking, thread-based multitasking, and a stack is a very good example with push and pop methods. Now we'll come to synchronization. Here, Java synchronization is a better option where we want to allow only one thread to access a shared resource. So, as I told you in the previous example, that is a stack. It has got an array, a character array, into which the push and the pop methods have to work. Here, push can be one thread and pop can be another thread. When can be called by another thread. So when push method works, it inserts the data, and correspondingly the pop method will retrieve the data. But then if it is synchronized, even if it is synchronized, there are chances that, but the number of times a push method has to work and the number of times the pop method will work, they won't one won't work in between the other. So there are, but you say the threads, we cannot control the threads. Threads running is that is when they get the priority, they start running. So we can't control a thread. So just for controlling, we can use synchronized method. So synchronization, why do we use synchronization? Is because to prevent thread interference and to prevent consistency problems. So in the sense, if I insert A, and then I have to, that's next it has to, I have to retrieve A. I should not insert B again. So A has to insert, when A is inserted, A has to be retrieved. When B is inserted, B has to be retrieved. If it's going fine in that way, then it's fine. But then threads are something which we cannot control, and there are chances that the consistency of the problem is consistency problems happen. The program is not maintained. So at that cases, there are chances that one thread works in between the other. So we use synchronization. And at times when more than one thread try to access a shared resource, we need to ensure that the resource will be used only by one thread at a time. And this process by which this is achieved is also known as synchronization. This is all done just because when we use the synchronized keyword before a method, then that method has to work, only then the next thread will work. So this is what is synchronization. Now there are two types of synchronization again, process-based synchronization and thread-based synchronization. And for thread-based synchronization, I told you this example of the stack is a very good example. And we'll see that over here again, the program. Here, now we'll see a simple example showing the implementation of synchronization and threads using inter-thread communication. So we'll see that also. And here a very good example is of a producer-consumer example. It's a very popular example and it's a very good example for synchronization and inter-thread communication. Here, consider a class Q. Here we have an integer value n. Boolean value set is equal to false. Synchronized int get is a method. While not value set, that is when while value set is true, only then you go to the wait method. You have to wait and we come out of this particular method. And then next, it is in the try block, so interrupted exception is being caught. Now system.println got plus n. Value set is equal to false. Notify method is called and return n. Now we'll come to the next part. That is synchronized void put. Here again we are synchronizing the methods just because they are using the shared variable. So the method has the values have to be shared, and so when it is the same shared variable, once when one thread is running, the other thread shouldn't work in between. So interference shouldn't happen. So here when I call the put method, n is being passed to it while value set. That is when value set is false, because by default it's false. So when it false, you have to come to the wait method. But false we won't get into it, because while will work only when it is true. So value set by default is true, so false. So we won't get into the wait method. We'll go down and then we'll come to this dot n is equal to n. Value set equals true. System.println put plus n. So what's the value of n? That will be printed over there, and we'll call the notify method. So we'll come back. Now this is what is written inside the Q method. So Q class has got two methods, get and set. Now we'll come to the producer class, which implements runnable. I told you actually implementing runnable is better for a thread. So this is the thread class. Producer is a thread class, and Q, the object of the Q class is called, and producer's constructor has got the parameter Q being passed to it. This dot Q equals Q, and new thread this comma producer dot start. So we call the start method of that new thread inside the producer class, and so the producer thread starts. Now since it implements runnable, we can call the run method. So public void run int I is equal to 0 while true q dot put I plus plus. So while it is true, the condition is true, so we are giving a true condition q dot put I plus plus. So the q method is object is called, and the q object is called, the put method is called, and I plus plus has been passed into it. So inside when we come to the put method, what happens? Value set's value is false. So while value set is false, you won't get into the wait method. The wait method won't be called, and will come below that. And this dot n be equal to n. The value will be assigned, and value set equals true will be assigned, and the print will print put plus n, and we'll call the notify method. Here, what happens is that the put value will be printed out. Now we want the consumer has to work. So class consumer implements runnable q consumer q this dot q equals q, and the thread is started over here, and then so the consumer and the producer both would be waiting over there. Now public in the runnable state. Now public void, and whichever one gets priority, it will work. So public void run while true q dot get. So if it is true, then q dot get. So when you call the get method, so initially if put has worked, then we have already notified, and values the value set value is being put to true. So not value set means the value is set as false. So wait won't work, and what's written under that will work. So got will be the value, that is got plus first value, that is 0, will be assigned to it, and value set becomes false notified. The same way, now this is what is going to happen when the get method is being called. So class prod cons public static void main string array of args q is equal to new producer q, new consumer q. That is, we are calling the constructors of the producer and the consumer class, which makes the both the classes both the threads running, and they come to the runnable state, and from there whichever thread gets priority it would run, and it will keep continuing unless we press the control plus C, and we can see the output. Here we have used the wait and notify methods. So in the output we can see that put, and it is synchronized also, and since not only that it is synchronized, also because the wait and notify methods have been called, not wait and notify, we are putting the value set as true and false. That was in the earlier situations that we had the wait and notify. Now we are calling it wait and notify methods are being called according to the value set. So we call the put. Once the put method is called, then the get method is called, then again the put method is called. So simultaneously it works in the proper way. So this is how we can control our threads by inter-thread communication. Now we'll come to the deadlock situation. Now what is a deadlock situation? Deadlock situation is nothing but when more than one thread is called simultaneously. That is, they are synchronized. When threads are synchronized, there are chances that only the lock is applied. That is, when one thread completes working, only then the next thread will start working. That is what is synchronization. So when one thread works, then the lock from the first thread has to be passed to the second thread, and then the lock from the second thread has to be passed to the third thread. Now we have 3 threads. Then if the first thread or the second thread doesn't work properly, then the third thread won't work. That is what it is. Because if there is anything that interrupts the first thread or the second thread, or any hanging up or anything happens, then the key won't be provided, the lock won't be provided to the second thread or the third thread, and then the system would hang. So this is what is deadlock situation. And we can see this frequently in our systems and all. Basically, if any particular task or any application is not working properly, then we can't go to any other application unless we close that particular application. So this is a very good example for a deadlock situation. So I think everything wouldn't have been very clear, the program and all things, because we have too many programs and threads to understand the last program of synchronization. Is just for you to make you understand what is synchronization, but then in the beginning itself, right from the beginning, how to create a thread and all programs have to be done, because with a shortage of time, limitation of time and all, I can't give you a complete idea of it. But then in our regular sessions, surely we'll be covering it that way, that I'll be making you do all the programs and all. So I think you have enjoyed your session over here. So you think it's good enough, then please like, share and subscribe. Thanks for attending our session on threads in Java.